and no one's been bothering me about the homework. Either that means that it's all too easy, or you just are like deer in the headlights sort of deal. Kind of like me staring and thinking, oh, that was a bad move. Now all I see is a little dot. Okay, but anyway, so let's just give this a go. This is a quiz for about the what is it, the quartiles and all that. So why don't we give this one a try? This will be good preparation for the test on Friday. Oh, welcome. Here we are. So give this a go. Take a few minutes. There's extras. You can sit back. Don't worry, there's another one. There's some. You need one more? Chipped. Good job. Anyone else? You got one? Oh, you need one more. I'm sorry. Wasn't even thinking. You got it. Thank you. Is this extra as well? Wow. Let's see. Yeah. Oh, by the way, just so you know, on the exam, I know some of you like to use your cell phone for the quizzes or whatever, but on the exam you can't. But I've restocked. I have all sorts of calculators here of different flavors and colors. And if you don't want a complicated one, there's some very simple ones that you can use. So if you need a calculator, you might want to start practicing now with it. But I've got plenty in here, and I'll have them out on Friday for you to use if you need them. Also, if your calculator just suddenly dies, I've got you covered. Okay, so let's get this going. Oh, attendance. Attendance. All right, hopefully you're coming down the home stretch here, but don't go ahead, don't pass it in this time. Something that I didn't want to tell you before, but now that you know, you'll know it for the next time, is that day before a test, I don't like to collect the quiz because I know that especially this quiz might be material that you would want to know and study about. So we're going to talk about it and correct it together so that you know what you did wrong and not do the wrong thing when you come to the test on Friday. Because, yeah, there's a question similar to this on the test Friday, so I want to make sure that we all get it right on Friday. So hang on to it. I'll just give you another minute or so, and then we will go over the answers. Oh, yeah. All right, well, let's go ahead and go over the answers. I'm sure you know how to do it. Maybe you're just polishing off that last thing, making that box plot look pretty for me. So what I'll do is I'll go through each of the answers and I'll explain to you how to grade yourself, okay? So you can give yourself a score, but if you're going to correct your stuff, then I'll assume that once you're done with the quiz, it'll be perfect, so you'll get a 100 for it. But there are a couple of places that I want to make sure that you understand how I'm going to grade your paper on Friday so that you can avoid any problems. If you've made a mistake today, that's great, actually, because you probably won't make that mistake on Friday. Okay, so let's go do the first one. Pretty easy, doing the mean, and I might make mistakes myself, so let me know if I got something wrong. I typed it into my calculator, and this is what I got. Is 252.9, so it's 1770 divided by 7 because there's 7 prices there. Does that sound like okay? Yeah, it's the only one that I'm like, well, did I type it right? Because if I slip fingers or whatever. Seems like it's reasonable. It's right in the middle. Okay, so that's that one. The next one is the median. So the median, of course, we have to put the prices in order. And there are 7 of them, so you'd have 3 on one side, 3 on the other, and you can see the middle one is there. It's 200. I'm sure you got that one right. If you did, you can put a little check mark or star, but if you got it wrong, just make sure you understand why you got it wrong and fix that before Friday. By the way, if you don't know why you got something wrong, you can either ask now, or you can come up afterwards and say, I'm kind of embarrassed, I don't know how to do this. Whatever, you shouldn't be embarrassed though, because there's some things that no one knows how to do because I never taught you, I forgot to, or whatever. So let me know, be the brave one. But anyway, yeah, so that's the median. The mode is the most common, and there's only one that has, one of the prices is twice there, so 190. So there's that. The range, so I don't know that we went over this, but it's pretty obvious what it is. It's just the biggest minus the smallest is the range. Gives you an idea of how spread out things are. So these home prices go from 180,000 to 550,000, and the difference, the range, that's a range of 370,000. So that's not that hard. Then we had the quartiles. Okay, so the quartiles, once you have this, you can figure out where the quartiles are because the first quartile is the median, the middle of that left-hand side, and the third quartile is the median or the middle of the right-hand side. So hopefully you got this. Interquartile range, this is, we just went over this last time, so you might be like, oh, fuzzy about it. That's just the difference between those two, so that's easy enough, just the difference between the quartiles. How wide is the middle? Now, what this does for us, and I know this data set is really small, just 7 people or 7 houses. But what this does for us is it tells us a range, sort of a band, where the middle 50%. If you think about it, the quartiles divide the data into fourths. And so if you have the first quartile and the third quartile, what's between them is half the data. So half the data falls in this range, and when you compare that with the range of all the data, it means that there are some pretty extreme home prices. So, because those are so far apart, you have 60. 60 is the range where 50%, half the homes fall in that range, and then when you go to all of the houses, it's like, wow, that's so big. So, and you'll see this on the box plot. So let's do, outliers. So now this one's also confusing. The first thing you do is you take that interquartile range, and you multiply it by 1.5. So 1.5 interquartile ranges, and then you subtract that from the lower quartile, the quartile 1, and then add that to the upper, the third quartile, and anything outside that, so if it's either lower than the 100 there, or bigger than 340, then we consider it an outlier. And so you probably could have guessed this just by looking at the data. You're like, well, that 550 kind of stands out. So you got all these houses that are all worth normal amounts, and then you got $1.5 million house. Although that's not that uncommon these days, I guess, depending on what market you're in. But in this particular data set, the 550 is an outlier. And then now the box plot. And here again, I just want to be really careful and explain how I'm going to grade this. So the first thing I'm going to look at when I look at your paper on Friday to see if you've made a box plot, I'm going to look for, first of all, a number line. So you remember, the first thing you do is make a number line. And I want to see a number line that looks like a ruler. It's got to be evenly spaced. Whatever numbers you have on it, evenly spaced. I'll show you mine. So that's the, now that kind of gives away the whole thing. But so here's what I'm looking for is I've got my number line. I don't care how it's labeled. You could label it by 50s or whatever, as long as it's evenly spaced. You can also put, once you've got that there, if it bothers you that you don't know what this is, you could put a little line here and say that's 180. That's fine. It's still evenly spaced. Same thing here. You could put a 250 here. That's fine. And you could put a 550 here. I don't care. But that's so, whenever I see bad box plots, it's usually, I'll show you a bad one in just a minute, but it's usually because student hasn't made a nice number line. Number line is terrible, and then once you've got your number line, you can almost not go wrong, because you're going to put your box around the quartiles. So I've got that, and then the line at the median. So once you've got your number line, it's almost impossible for you not to get 100% on your box plot. So anyway, it should look approximately like that. Now some of you might say, wait, didn't you say that outliers should be little circles? Yeah, you can put a circle there instead. I'm fine with that. Put a circle here and then bring this tail back to whatever the interquartile range would have been. Or even further, you could say like, whatever the biggest data point that's not an outlier, that's fine too. But there's either one. So either if you have a circle here, if you did that, good job. If you did it what I did, great. Let me just show you a bad box plot, because you might be wondering, how could anyone do this wrong? Because it's so easy. Okay, here's what they do. Notice that your 5-number summary is 180, 190, 200, 250, and 550. So there's the 5-number summary: minimum, quartiles, median, maximum. So here's what I see some students do. They make their number line. You'd think, okay, can't go wrong. They put their little lines on here, nicely, evenly spaced. Perfect so far, right? Now here's where they go wrong. They label these like this: 200, 250, 550. And then they put a beautiful box plot right above this. That's beautiful, but the problem is that the gap here is 300, whereas the gap here is just 10. Those should not be the same size. Now, if you did this is wrong. You should mark it wrong. Take off points. Well, don't, because you're going to fix it. So if you did this, it's okay, because you got it out of your system. Yeah? Move on. Make sure it looks like this, and then you'll get a smiley face. Okay, so any questions about that? Any of the quiz problems? Do we have this? We're good? We're happy? Reasonably happy. I know, it's hard on Wednesday morning to be ecstatic. All right, so here's my job today, or what our job is. We have an exam on Friday. And so what we're going to do is I want to first of all just take a look. I've already got your exam printed up. It's not in my office yet. I hope it's there when I get back from this class, or my second class, but we'll see. I've sent it to the printer. Let me go, we're not here, just a sec. But on our webpage, you will find, is this it? Yeah, you'll find this. Let me just show you real quick, just in case you're not sure where to find it. Here is our Moodle page. Just bear with me for a sec. So there's our Moodle page. Here, let's get rid of this side here, close, whatever. And go down and you will find under practice exams, you will find this. Let me just double check. Is this the same thing? Nick, running temperature? Yeah, that's it. Okay, so you'll find it there. So if you hadn't found it before, that's where you'll find it. I think I mentioned on Monday that it was there, but you might not have looked at it. So that's the first thing. I wanted to make sure you knew where it was. Now, one thing that you'll see is lacking is the answers. I was starting to write up the answers for you yesterday, and then I thought, wait, why am I doing this now? I'm going to do it, I'll do some of it now, and then I promise to finish it this afternoon and put it up online. Okay, so that's the first thing to note. The second thing to note, hold on a sec. Should have had this ready. I'll pull it up. Give me a sec here. I'll show you the actual exam. I know, you're excited. Let's see what this exam looks like. Just a sec. Date modified. I have to find it. Where is it? Didn't I make this exam? No world. Oh, test one? Sorry. Oh, there it is. I don't know why I couldn't see it. Right in front of my face. It's called test one. Okay. So let me just show you. Wait, why did they change the way that these things look? View, can I view this? Oh well, I guess I'm stuck with the way, I don't know how to, yeah, it used to be that I could show you the whole exam at once, but here's the front, so here, see, look, yeah, there it is. Okay, so it's 4 pages, so I wanted to show you, the reason I'm showing you this is that if you compare this with let's see, where's my, there it is, iPad. If you compare it with this, now this one, how many pages is this? I think this is longer. 6, yeah, it's 6 pages. So this one is longer than the actual exam. So obviously I've shortened some things, but I just wanted to show you that you have a lot of the same things. Like you'll see this thing here? I've got that exact question, but it's not weights of students and genders of students. It's something else that I've put in the little block there. Here, you can actually see it. Do you see it right here? Look, it's right there. So if you can do the one on the practice test, you can do this one. I make these embarrassingly similar. Don't tell my boss I do this. I think I'd get in trouble. But if you can do the practice test, so this just gives you some material to work with. Okay, so with that said, let's just take a peek at what the practice test, one other thing before I go on, is your class is actually small enough that I don't have to do this, but I decided to anyway. You'll notice that this is exam 1 with the little symbol, the spade symbol there. I actually make 2 different versions of the test, and that way I can alternate and give Noah one version and Allie else? Yeah. Okay. So yeah, because then they can't peek at one another. But anyway, so you can sit next to each other. The reason why I say this class is small enough that we wouldn't have to do that is there are actually 24 tables in here, so I could spread you out. But what's the fun in that? It's more fun to have 2 different versions, because later we could compare the 2 and see if one of them is easier than the other. That's always fun. But anyway, getting back to this, so that's something to note. So let's just take a look at this, get started on it, and then I will finish it later. And I'll take, if you've already looked at it, you might say, this is the stuff that I really need help with. So anyway, Nick always causes problems. Whenever I give this exam, I always have Nick doing something for me, And it seems like he's always having, you guys have trouble with Nick for one reason or another. So this harkens back to the very beginning when we're talking about these definitions, sample, population, etc. And so let me just remind you what these are. We're not going to do everything right now. Like I said, I will get the rest of it done and put it online. But Nick here wants to estimate the average running temperature of computers being used at MVNU. So he surveys, so you might wonder, how does he do this? Well, my computer seems to always be overheating, so I've got a little app that monitors it. Look at this, 94 degrees. It's Celsius, by the way. It's right now running at about 60 degrees Celsius. I don't know why it runs so hot. I try to keep it cool. But anyway, there's that. So I thought, well, you know, Nick can help me out. I want to know, am I unusual? Is my computer special? Anyway, so he's going to go survey 50 randomly selected computers and measure their running temperature using an app like that. So I just need to know the sample, the population, the statistic parameter, and the variable. I think you can probably do this, but let's just go through and remind you. Sample, of course, are the things that I actually observe. So it might be helpful to note that whenever you do this, the sample and the population should look the same. It's the same stuff. You've got a population over here, and you grab your sample out of that population. So population, let's see, we're interested in computers, right? Computers at MVNU. So let's just do the population first. MVNU computers. And then he surveys 50 of them, and so the sample is the 50 computers that he actually looks at. So 50 MVNU computers. But you're going to see this with every problem like this, is that whenever you do it, sample and population are going to look exactly the same. Just one of them is going to be more specific. It's like, well, it's these computers, not all the computers. It's that one there and this one. Those are the ones I'm sampling. Parameter and statistic, same thing. Parameter and statistic are going to look exactly the same. The thing, though, to note is that the sample and the statistic are related, and in the same way, you have the population and the parameter are related. So whatever the sample is, or sorry, whatever the statistic is, the parameter will look the same, but it will be coming from the population and the statistic from the sample. Are those highlight? They're different. Well, up here, when you look at it on your computer screen, hopefully you'll be able to see the difference between the orange and the yellow. Maybe I should do this in green there. Oh, now it looks kind of like sickly green. Whatever. Okay, so onward. So let's see what we're doing. What are we measuring? We're computing the average running temperature. Okay, the statistic will be the average running temperature of the computers in the sample. So average running temperature, computers in the sample, and the parameter is exactly, in fact, watch this. I'm going to just take this. I know you don't have this able to do this on the test. I wish you were. But here's the average running temperature. It's the exact same thing, but instead of the sample, it's the population. I mean, I could say the average running temperature of all MVNU computers. That would work as well. But as long as you're evoking the population when you talk about the parameter, great. Finally, the variable, this is what you're actually measuring. You have to imagine yourself being Nick, or you have to imagine Nick being Nick, and going and doing what he does. And what he's going to do is he's going to turn on this computer right here, and he's going to say, okay, what is the running temperature? And then he'll pull up the app, which he probably has installed on some sort of a flash drive, and he'll say, oh, this computer looks like it's running around 60 degrees, so you have to keep bouncing around, I guess, because things get excited or whatever. So that would be the thing that he measures. So each computer has its own measurement, and it's the running temperature. Running temperature. That's terribly messy. Sorry about that. Try to be less messy than me. I know that sounds like do as I say, not as I do. But if it's really hard for me to read, then I start getting angry And you don't want me to grade papers when I'm angry. So yeah, just, write down as neatly print instead of using cursive. No one knows cursive these days anyway. Yeah, so do your best to make it as neat as possible. And that's that. Okay, so one other thing I wanted to mention here, the reason I picked this one, like I said, I'm not doing all of these, I just wanted to pick a few, is that I wanted to point out that when you answer these questions on the actual test, this parameter and statistic, they're always going to be one of two types of things. Either you're going to have an average, kind of like the thing we have here, or a mean. Average, mean, same thing. So either you're dealing with an average, or you might be dealing with a proportion. So maybe I'll just do this. Parameter, it's either an average or a proportion. If you don't like the word proportion, just use a synonym, like percentage. That's fine with me. But anything that is that, like the fraction I could take too. Whatever, as long as it's always going to be one of those two in this class. If you go on to, like if you're a social work major and you have to do advanced statistical modeling for social work, then you're going to have to learn about other parameters. But for this class, all of the parameters we care about are either averages, means, or proportions. So when you get to this on the test, it's one of those. Okay, speaking of parameters and statistics, let's take a look at number 2 just briefly, and then we'll skip ahead. But since we're on this statistic and parameter thing, I'm going to try my best. Well, it's already at the printers, so I've tried my best to make this super clear. Remember that statistic refers to a sample. A parameter is a number that refers to a population. So when you look at these two, or however many I put on the actual test, what you're going to ask yourself is, does this number, 157, is that a number that refers to just a sample, or does it refer to everyone? So let's see, does it refer to everyone, or does it refer to just a sample? It says the Health and Fitness Club found that the average weight of all members, so I realized that all of its members technically are a sample taken from the population of everybody in the world. But I think that when I say all members, that should sort of be evocative of this idea that we're looking at everyone we care about. All the members in the population that we care about are that. So that one's going to be a parameter. Parameter is everyone. So that's the population. And then let's see, a professor surveys her class to get an idea of what students at her institution. Right there, let's just stop. And notice that this professor is surveying her class to figure out what happens with everyone in the population of students. So she's not getting, asking everyone at the institution, just her class. So that's a sample taken from everyone. So that number is a statistic. So statistics only are numbers that only apply to samples. So that would be a statistic there. Okay, so another one, so we'll pause just for a minute in case there's questions. So yeah, I'm going to sort of scroll through. We'll get to all the pages, but I'm not doing them all right now. So if there's something I skip and you're like, wait, I don't understand that one, just let me know. But like I said, I will eventually do them all, and I'll put my answers, like this actual thing, you'll see all of my pen markings on Moodle later today once I get done with all this. Okay, so here's one, and the reason I wanted to highlight this is that for some reason, students, when I've graded this in the past, or problems like this, they either get them all right, or they get them all wrong. And if you get them all wrong, it's devastating, because now there's fewer of these, like how many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. That's if it's 2 points each, which I think that's what I have on, I forget how much each of the things are worth on the actual test, but let's say it's 2 points each. 2 points makes 20 points in this table for this particular, all of these. And so if you get them all wrong, it's devastating. You go from 100 to 80, probably less than that. So I just want to clarify a few things, and then we'll go on. But if you need me to clarify more, I'll fill out the table fully later. But for now, I just want to clarify a few things. Remember, nominal are things that are just categories. Just categories. Ordinal, you can put them in order. Small, medium, large. A Likert scale, some of you know about that, like you strongly disagree, neutral, agree, strongly agree. That would be ordinal because you have things in order. So that's ordinal. Interval and ratio sometimes gets a little confusing, but one way you can think about this is just ask yourself, does it make sense if you have a number? So numbers are interval or ratio. Is that number, does it make sense to talk about the ratio between two people? We'll look at this in just a sec with this. And if it is, then you do ratio. If it doesn't make sense, just do interval. So let's see if we can identify a few of these, just a few. And every now and then I'll accidentally, like I make up new ones all the time for this type of a problem. I might pick something that is debatable. Like it could go in maybe one of, like you might be able to argue that, no, like temperature. Some of you might be thinking, I'm a scientist, there is an absolute zero, so ratio would make sense because we should all be using Kelvin. Okay, whatever, but temperature, usually you think of temperature as being interval, not ratio. Okay, so let's get back here, especially because of how messy Fahrenheit is. It's just stupid. Why do we use Fahrenheit? But anyway, getting back to this. So let's look at a couple of the numbers just to get, so letter A, weights of students taking statistics. Does it make sense for me to say that, that Blair is twice the weight of Noah? If I say that, that makes sense. It's a number, and it would make sense that, if you could think in your mind what that would mean. And so because of that, this number goes here. So I guess we have this dividing line. So these two, whoops, do this. So let me just highlight this. These two, those are numbers. And then these two here, those are categories. And like I said, you might be thinking, this is so basic, I don't need this. But it always is heartbreaking to me when I'm grading someone and they get every one of these wrong. Like, for whatever reason, they put the numbers over here and the categories over here, and I'm like, oh, this is like a whole bunch of points, and you just dropped a letter grade. I hate that. So, contrary to popular belief, professors want you to do well. If everyone got an A, I'd be thrilled. But anyway, getting back to this, so we've got this so far. Genders, okay, we don't need to do that. I think we know. Well, maybe I should just mention, whether you think that women are better than men, it doesn't matter. We're going to go with nominal for genders, all right? Because it's not ordinal. So genders are going to, I might as well put the check there. Okay, salaries, let's see. Let me find, birth years. Oh, I like that one. Okay, let's go down to birth years. So birth years are numbers. They're numbers, but it doesn't make sense for me to say that my birth year is 95% of your birth year. Because there are different scales. You have the Chinese calendar, you have the Gregorian calendar, the Julian calendar, the Jewish calendar. They all have different starting points, and they all have like different, what does it mean for me to be 95% of you? In fact, it's probably even closer to 98%. Whatever, it doesn't make sense. So, I think it would be 98%. Would be my birth year compared to yours in the Gregorian calendar. So because of that, these are numbers, and it does make sense for me to say that my birth year is 38 years different from your birth year. I'm guessing it's about that. So wait, is that right? No, that's probably not quite right. I was born in 68. It might be 38. Yeah, you can do the math. Take the difference between 1968 and whatever you are, 2005 or 6 or whatever it is. Okay, so there's that. We already talked about gender of dogs, birth months. Okay, so this one. This one's one that I've put on exams in the past, and I've had students argue with me about it. And so this is one where I would actually, if I put it on your exam, I would accept either of the categorical things. Because some people might say, wait a minute, birth month is a category, nominal. There's not really an ordering, but there is an ordering, isn't it? It's like January, February, March, April. It goes through the year. So I personally would think of this as being ordinal because there is the ordering, but I've had students come up and, like afterwards, you'll see this on Monday when I give your test back to you. I'm going to say, if you do have a complaint, come see me afterwards. Every now and then, a couple of students will come up mining for points. They'll say, oh, I think it's this way. And I'm like, sometimes I actually agree, but I usually don't. But do make those arguments. So anyway, that one I might take, but anyway. Eye color, that one is a category where there isn't an ordering. So there's those. And then one last thing, I usually do have zip codes or something like this, like social security numbers on my exam. Zip codes, social security numbers, anything like that is not a number. Well, it's a number, but it's not interval or ratio. That's categorical. So it's going to be a nominal. So there's that. Okay, so let me move on. Like I said, I'm just interested in the ones that cause problems. Usually you don't have trouble with this. There's a few people that might have a little bit of trouble figuring out the whole, just make sure you know what those mean, what types of sampling techniques. And then I've got a little description here, and you're supposed to match. But we can go back to that if we need to. So the next batch, I've stolen some problems from Newton. And so this is just, your problems will be different from these problems, but I just want you to be aware there's probably no way to really prepare for these, and you're going to see these problems be like, did we go over that? Yes, we did. I took them from Newton. You did them, or someone did them at some point. So it's questions like this, and they're mostly in that section. Oh, there was a section about bias and stuff like that. I forget. But anyway, you can see that's these categories here are like that. So I will put the answers up, but so you can practice and see like, oh, did I get it right or wrong? But I don't know that there's any way to say that because the actual ones on the test will be a little bit different than these because I picked different ones for the test. Okay, we've done this, and I think we're good with this, but there may be a little bit confusion still with this table. So just to remind you, I won't do the whole thing, don't worry. I just want to remind you of this. There are 40 students. I'll always tell you how many, and then you'll notice that I don't have all of the students. We need to fill in this blank right here. Actually, we're going to fill in all the blanks. So that blank there, since there's 40 students, we have 36 accounted for, I believe, if you add up those three numbers. So 2 plus 25 plus 9. Maybe I'll do this for anyone who's just reading this. Is 36, and then I do 40 minus 36, and I get 4. So that's going to go there. That's the first task. And then you have to get relative frequencies and cumulative relative frequencies. And I don't care how you do this. You can do this as 2 40ths, 4 40ths, 25 40ths, and 9 40ths. Or you can do this as 0.05, 0.10, whatever that is, and whatever that is. So I'm too lazy to figure it out right now. But you could just do it as a decimal or a fraction, I don't care. Most students don't have trouble with that. I generally, when I grade this, it's like you figure that out easily, and then this. But this, for whatever reason, whenever, and I'm giving you like pro tips from like, I have memories. I teach this class just about every semester, and for some reason, like half the class gets this column wrong. And so I'm showing you this because I'm begging you not to get it wrong. It would be great if no one got that wrong. Okay, so let's remind you, cumulative. Cumulative. It means we're accumulating, we're putting things together. So we start off with the first one. It's just going to be 2 40ths. So you just write that over there. But then the next one, this is 4 40ths plus 2 40ths, which equals 6 40ths. And so what's happened here is you've taken these two and put them together to get that. Now the third one, I think I'm not going to do all 4 of them, but well, I will eventually. But the third one is going to be 25 40ths plus the previous ones. And I realize that this is very inefficient the way I'm doing this, but I want to emphasize how this comes about. So 31 40ths is this one here, And of course, that came from taking these three and adding them up. So it's cumulative. We're accumulating this stuff. The last one, by the way, no one should get the last one wrong because it's always 1. 44, whoops. It was dumb. Let me try again. 40ths. Yeah, it's always, so you can just put a 1 at the bottom in that column. Because if you've done the math right, it should be just 1. So don't get that one wrong. It'll be discouraging to me and to you. You don't want to be a discouragement to anybody. Okay, there's a few more that I want to make sure I hit, and I think you're pretty good with this. Just remember, I can't remember if I don't have all the graphs on the test, because it just, like I said, I don't want to make it 6 pages long. It's only 4 pages, that way I can make it into a nice booklet. But, so I don't have all of the graphs, but you'll have at least one graph. And so this graph, let's see, what are the 4 graph types? We have histogram. This is a histogram. So histograms, the main thing, I mean, I think you're good with, you can figure out how to do this. 60 to 64, put a bar. That's easy enough. And then 65 to 69, no bar because it's 0. 70 to 74. Give me a sec, I should have started out on the other side. So there's a bar there. And then 75 to 79. Here's the crucial moment to make this a histogram, is that the bars are smashed up against one another. They touch. Some of you did this wrong, which is good to get it out of the system. And I gave you your quiz back, and I said no gaps, no gaps between bars with a histogram. So histogram, there's no gaps. I know there's a gap right there between these two, but that gap is meaningful. It means that no one was in that category. So no gaps between the bars on a histogram. If this were a bar chart, so let me remind you of the others. Do I have the other ones? Oh, that's a bit of a mess. Okay, so apparently something went wrong with the typesetting here, but you can make your own. So this is a bar chart. This one you should have gaps. So you'd have business, and how many are there? Wow, I can't even tell. Oh, I think here we go. Here we go. It's this. There's the frequencies over there. Sorry about the mess here. Yeah, there they are. Okay, so business has 3. 1, 2, 3. And then the next one is math. And notice with a bar chart, there are gaps. So that's the difference between, so bar chart, put a gap. If it's a histogram, no gap. Pie charts, I mean, you've been doing this since you were in 3rd grade. Hopefully you know how to do this. But here, this one, I tried, and I do this on the test too. With the quiz, I tried to make it as obvious as possible. This one's half of the people like chicken patty as their favorite food. And we had chicken patty on Monday. It was such a glorious day for me, going to the cafeteria and getting my chicken patty. But anyway, so this is all fiction, by the way. I know your favorite food is probably pizza, but anyway, so 50%, and you could figure out the others, but this is just asking about the percentage of chicken patties. And then the other graph was the line chart. Remember the line graph? And line graph is usually a time sequence graph, and so that, I don't think I have an example here, but you know how to do that. Draw the dots and connect the dots, basically, and you'll be fine. Okay, we've done mean, median, and mode already today. But if we need to, in fact, this is almost exactly like your quiz. So this one's easy. You've done this. But if you need practice with finding the mean and the median of something like this, do the practice. I'll have the answers here in just a bit. Well, later today. Grouped frequency distribution, the main thing here is you're going to come up with a midpoint for each of these categories. And the midpoint is literally the middle of the category. And that's what you're going to use for the, so 6 plus 10 divided by 2, that's 16 divided by 2 is 8. 11 plus 15 divided by 2 is 13, and so on. So then I'll use that midpoint to compute, and I'll do midpoint times the frequency here. So you'll see me do this, or I'll do this and I'll upload what I have. Same thing up here when I'll do age times frequency here and add them up. So I'll deal with that. I can do it now if you want, but I'm looking at the time. I want to make sure I get through the whole thing. Just mention the things that students like to get wrong. This is exactly like the quiz. And yeah, that's it. And then, oh, why do I have so many of these? I don't know. Maybe that's why it's 6 pages. So yet another one that's like that. That's easy. Oh, here we go. So these words. I think this was on the homework. Well, if not, you've got some box plots here. We're going to talk about it right now. So skew. I know we've done this. Here, let's just do this. Let's say that we have a, let me go back up here. Is this one skewed? Yeah, this one's pretty, yeah, this one's pretty skewed. Let me just work on this just a sec. So this is 4. It'll just take me a second to do this. Oh no, undo. Up to 7 is the next bar. And then the next bar is up to 9. I'll label them in a minute. And then the next one just goes up to 1. And then this one is 1. Okay, so this is 70, 80 to 84, 85 to 89. Yeah, 90 to 94. Give me a sec here. 95 to 99. Okay, so you'll notice that the general shape of this is, oh, actually the word is here. They're here. Letter B, I just missed it. This is skewed left. It's skewed left because the bulk of the observations are to the right. I realize that there are a couple right here. You have this big bulk, and then it kind of slopes off to the left. So if you look at it, and it looks like a ski slope, the direction of the ski slope, not the cliff, this is a cliff, the direction of the ski slope or the hill that you wouldn't mind walking down or up, that's the skew. So this one is skewed left. So you have stuff here, and then you go this direction, and that's what skewed left means. So if the bulk of the stuff is on the right, tapers to the left, that's skewed left. If the bulk of the stuff is on the left, and it tapers to the right, that's called skewed right. And you can actually see this in histograms. Give me a sec. Put this quiz back up here. This histogram is skewed right. I mean, you can actually see this. The bulk of the observations are here. In fact, 25% of the houses, I realize we only had 7 houses, but whatever. 25% are here, 25% are here, 25%, and things get more spread out as you go this way. This is skewed to the right. So skewed, also, when you have a box plot, it's the direction of the long tail, or if it's like this. If the tails are about the same, then we'd say it's symmetric. Oh, why did I do that? I'm going to go back here. Give me a sec. Okay, so getting back to this, the very last stuff here, and then I'll take questions if you have any. So, oh, and one other thing is that when you have skewed data, one of the hallmarks of skewed data is when the mean and the median are very different. And if the mean and the median are far apart, notice that this, I know that 252 is not that far from 200, but what the deal with the mean and the median is the median is the middle. The mean gets pulled by the big or very small number. So that 550, if that 550 weren't in the mix, the mean would be much closer to the median. But because of that 550, the 550 is pulling the mean up towards it. So that's another hallmark of skewed distributions, is that you will have the mean and the median will be quite different or largely different. So here, like this, if the mean is 340 and the median is 293, it means that this is probably skewed towards the right. So that's that. Think about, like, here's 293 is the middle, but then the mean is over here somewhere, which means there's some big numbers that have pulled the data or the mean upward. So that'd be skewed to the right. If the mean is 20 and the median is 25, so the median is 25, the mean is over there, probably skewed to the left, probably, but not 100%, but probably. So I'll choose that. And then these box plots, you can see this is a beautiful symmetric box plot. Notice that the box and then the whiskers, they're almost exact. In fact, I probably made it so that they're exactly the same length. So that's symmetric. So those data are symmetric, and then this, you can see the data is kind of squished together on this side and spread out over here. So that means skewed this direction to the right. Okay, so I know I blew through this super quickly. I will finish this, but I was just curious if there's anyone who is panicking about one particular type of problem. It's very indicative of the actual test. If you know how to do these, you're going to do fine on the actual test. I will be around tomorrow, so come by and visit. I'll make you a latte. No one's come and gotten like a double shot or anything like that. So I can make you whatever you want on my little machine in my office to caffeinate you, and we can talk about this. So I will put up the rest of the answers later today, tomorrow morning at the latest, but probably later today. Otherwise, have a great day. And oh, sorry, one more thing. I will be in this room probably at 7:30, maybe 7:35. I get here pretty early, and I will start passing out the tests. So if you come here at 7:50 and you see everyone working, you're not late. It just means that I've already got the tests and people have come in and decided to start. You can start early if you want. So just, I know some people, they get really panicky when they see that. So you're not late.